Here we're going to continue looking at the graphs of quadratic functions in standard form, and we've added an additional variable to this function. F of x equals a times the quantity x minus h squared plus k. The k is the new addition, and this k will either shift the graph upwards if k is positive, or downwards if k is negative. Notice that k greater than 0 could shift a opening downward parabola up for 2 solutions, or an opening upward parabola with 0 solutions. Solutions I'm just referring to as the intersections with the x-axis. So this can have several different effects. If the function is opening upwards, you could have no solutions either way if you shift k upward if it's opening upward, and if you shift the function down or make k negative when the function is opening downwards. Either way, you get no intersections with the x-axis for both of these examples. But if your function is opening downward and you shift k, or shift the function up or make k positive, you get 2 solutions for the first scenario and 2 solutions for the second scenario when k is negative but the function was opening upwards. So now let's look at some other interesting things that have happened. The vertex is no longer h, 0. It is hk. So h represents the shift in the x direction and k represents the shift in the y direction. And the domain is -infinity to infinity for all 4 scenarios listed here, but the range will depend on whether the function is opening upwards or downwards. The minimum or vertex value is always included as the end value for these parabolas. And if a is greater than 0, the range for the function is k to infinity, including k, and if a is less than 0, the range of the function is -infinity to k, including k. K would be the maximum value. That's another way of saying what I just said. So now let's look at the activity. The information I just gave you is here for you to reference later, but now we want to practice a function, practice by graphing a function of the form f of x equals a times the quantity x minus h squared plus k. Let's use Desmos to do this. Once again, we have this format. We're going to leave the parabola, the standard form, there in black, and then I'm going to add an additional variable to a x minus h squared by adding k at the end. And we'll add a slider for that as well. And now you can see that the blue function is representative of all 3 variables. So let's set h to 1. And let's set a to be positive 2. Let's make it 2. There we go. And let's see what happens when we shift k. K should shift the function up or down. And that is exactly what it does. Notice that the other variables or sliders are staying constant. Now, if we were to shift the function to the right, that would be changing h. So we will shift h to the right. Let's make it 6. And now let's shift k. So making k positive will shift the function upwards. Let's make it go up to 10. So now we have the function with scalar in front, positive 2, so the function opens upwards. We have a horizontal shift of 6 to the right, and we have a vertical shift of 10 upwards. So my coordinate point for the vertex right here should be the values of h and k respectively. And it is. The minimum for this function is at 6, 10. That's the coordinates for the min or vertex. My axis of symmetry would be along the line x equals h. So let's go ahead and just type that in. X equals 6. And sure enough, that is my axis of symmetry. There is an equal amount of parabola to the left and to the right of this vertical line. I'm going to go ahead and make that a dotted line. And then finally, we want to know what the domain and range is for this function. The domain is all real numbers, also known as -infinity to infinity. The range is from the lowest point upwards. So we will go from 10, and that's a bracketed 10 because you're including the minimum, to positive infinity with a parenthesis.